Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today, we have learned the subject on MR3452 Control Systems Engineering for 2021 regulations. Now, we are going to discuss the topic state space analysis. So it is a modern approach used in control systems to model and analyze dynamic systems using state variables and matrix equations. Introduction. So state space analysis represents a cutting edge and a robust framework for designing and evaluating control systems. So the limitations of the transfer function methods assumes zero initial conditions applicable only to LTI systems, and it's suitable mainly for SISO systems, single input, single output systems. So it does not provide information about internal states. So the state space analysis overcome these limitations, and it suitable for computer based simulations and modern control designs. Benefits of state variable analysis. So it can be applied to wide range of systems, including linear systems, non-linear systems, time varying systems, time invariant systems, systems with multiple inputs and multiple outputs, MIMO. And it also provides detailed information about the internal behavior of the dynamic systems also. Concept overview. So the output of a system depends on the current input and initial conditions. So the initial conditions are present at t equal to t naught. So here the variable that describes the condition of the system at a particular instant is called the state variables. Definitions. So it introduced important terms: state variables, state vector, and state space. So what is meant by state? State is a minimum information needed to predict the future behavior. Then state variables. State variable means the variables describing the system condition only. Then state vectors. So this is a vector collection of all state variables. Then state space. It is a mathematical space formed by state variables. So these concepts form the foundation of state space analysis. Illustrations. So the circuit example demonstrate how electrical quantities such as capacitor voltage and current can be chosen as state variables. So the system dynamics are represented using differential equations. State equations overview. So the dynamic system can be represented using first order differential equations called state equations. So for a system with n state variables, so there will be a n first order equation describing the system behaviors. Then state space model. So state space model consists of state equation and output equations. So the state equation describes the evolution of state variables, while the output equation relates states and inputs to the outputs. Output equations. So the output equations expresses how system outputs depends on the state variables and input variables, and it also provides the measurable response of the systems. Selection of state variables. So it discusses guidelines for selecting the state variables. So equal to the number of energy storage elements, and it is equal to the order of the differential equation, and it is equal to the highest power of the s in the transfer function denominators. Then state space modeling with physical variables. So physical quantities such as current, voltage, position, velocity. So these can be selected directly as state variables to simplify the modeling. So this is one of the example for a state space model. The circuit contains one inductor and one capacitor. Since there are two energy source storage elements, two state variables are selected. That is inductor current, capacitor voltage. The example derives the state equations for the circuit using circuit and chosen the state variables. The equation describe how current and voltage change with the time. Three-state system example. So the circuit contains two inductors, one capacitors. So therefore, three state variables are required to represent the system completely. So the solution approach, the selected state variables are current through inductor 1 I1, that is represented by I1, current through inductor 2 represented by I2, capacitor voltage VC. So these variables are then used to formulate the state equations. Representing state with phase variables. So phase variables are formed from output variable and its successive derivatives. So this method is useful when deriving state space models from differential equations or transfer functions. So phase variable model, it shows how higher order differential equations can be converted into first order state equations using this variable, phase variables. So advantages of state space analysis, it is suitable for MIMO system, that multiple input, multiple output systems, and it includes initial conditions naturally, and it supports nonlinear systems. It is easy to computer implementation, and it compact matrix representations, and it also useful for digital control systems. Disadvantages. So it includes requires matrix and linear algebra knowledge, and it less initiative than transfer functions, and it manual calculations can be complex, and physical meaning of state variables may not always be obvious. So applications, it is widely used in control system design, robotics, power systems, aerospace engineering, mechanical systems, and industrial automation. This list the reference books used. So these are standard textbooks in control systems engineering. Thank you.